Hey everyone, we are going to be talking about identifying properties of operations today. So you will need a calculator and pen or pencil, as well as the properties of operations packet. If you're an online student and you picked that up today, awesome. If not, I have attached it to the Google Classroom assignment, so it is there. You will be turning that in as well, so keep that in mind. And then just a couple reminders / announcements before we get into the lesson. There was a short assignment on Google Classroom on Friday. Please make sure that you have done that. I would even suggest doing it before you do this lesson. That way you're not just coming into properties of operations like totally blind. So that's what we're going to be talking about today, properties of operations. Tomorrow we're going to be doing a unit review. And then Wednesday we're going to take a quiz. Thursday, if you're an in-class student, there's an enhancement. So that's kind of the plan this week. So we're going to be talking about several different properties of operations today. But I wanted to kind of talk about what properties of operations means. Basically, they are just rules that help us organize problems so they don't look as scary or complex. They also help us find equivalent expressions, and they help us simplify expressions. And all of this will actually make a lot more sense when we go into these in a lot more detail after Christmas break when we start Module 3. So today we're really just kind of going over the very basic overview of each of the properties and how to identify them. But then when we get back from break, we'll start actually using them with solving equations and things like that. So let's just jump right into this. Properties of operations. So on that packet, you're going to see on the very first page, there's like a big table, right, with a bunch of different rows and columns. That first column tells you what property we're looking at, so commutative property, associative property, etc. The second column says with variables, okay, and that's just giving you like the very generic idea of what's happening with that property. The third box, that's what we're going to be writing important information in today. So just so you know, like where you should be writing stuff or where it would be helpful for you to write stuff. Okay, and I'll highlight what important information on each slide you would need to write down. So we're going to start with commutative property. Commutative property. The important thing to write down for commutative property is reorder. And if you can manage it, and I know you can, I would also write down same groupings. Okay, but reorder is really the most important part there. So before we get into what commutative property is, I'm going to give you a way to maybe help you remember that it means reorder. So think of the word commutative and that kind of root word there, communicate, okay, communicate, commutative. So if I were to say, I have blue eyes, and then if I were to say, these two sentences, so I have blue eyes, and then blue eyes I have. They both mean, the meaning of both of those sentences is that my eyes are blue, okay? But you'll notice that we actually rearranged these words, right? I have and blue eyes were kind of swapped, right? Blue eyes first, then I have, okay? So think about commutative property as essentially the same thing. we can reorder numbers, or in this case, phrases, but the meaning or the solution will still be the same. Okay, so there's kind of a good way to remember commutative property. Basically, and there's commutative property of addition and multiplication. I'll go over both, but essentially it's saying that you can reorder things and you will still get the same answer. So let's go over a couple examples so you know what I mean. Let's say I have 3 plus 5. 3 plus 5. We know that 3 plus 5 equals 8. But what if we reordered it so it was 5 plus 3 instead of 3 plus 5? Well, we would still get 8, right? And that's essentially what commutative property is saying, is we can reorder what we're adding, but still get the same answer. Okay, so there's a good example that would probably be helpful for you to write down too. This also works with multiplication. So let's use different numbers. Yeah, let's do maybe 2 and 6. If we multiply 2 times 6, we get 12. Commutative property says that we can reorder those numbers, so 6 times 2, and we'll get the same answer. And that is definitely true. They both equal 12. Okay, so there's a good example of commutative property of multiplication. Now, the key thing here that you have to pay attention to is the type of operations you're using. By operations, I mean multiplying, adding, subtracting, dividing. Okay, if I were to give you, let me scroll over here for a second. If I were to give you this problem, 3 plus 5 times 2, and I told you to reorder it, and let's maybe just switch the 2 and the 5 around. Would these equal the same thing? So according to order of operations, we would do multiplication first, right? Multiply, then add. So 5 times 2 is 10, plus 3 would be 13. Okay. Over here, we have multiplication first, so 2 times 5 is 10 plus 3. If we add those, we get 13. So those work, but what if instead of doing 3 plus 2 times 5, what if we reordered like this? So in this case, I'm swapping the 3 and the 5, okay? So let's find the answer to this and see if they're all still equal. So again, multiplication first. 3 times 2 would be 6, plus 5 would give us 11. So they do not, in fact, equal the same thing. So what's kind of a tricky thing to look for with commutative property is that you have to either be adding everything or multiplying everything. So adding everything or multiplying everything for it to actually work. Okay. The exception to this would be if you are using parentheses. Okay, what I mean by that is, let me give you another example. We'll stick with the 352 actually, but throw in something a little different. So if we had 3 plus 5 times 2, but we had 3 plus 5 in parentheses, and we were asked to reorder this without changing the answer using commutative property. There are several ways we could do this. The key thing would be to, and again, this is why I wrote same groupings on here, same groupings, okay? If you had something like this and you were asked to change it using commutative property, you have to keep what's grouped the same. Okay, So what I mean by grouped is what's inside the parentheses. So right now we have 3 and 5 being added into parentheses. So you have to keep the 3 and the 5 being added in parentheses for this to work. But there are other ways we can reorder things, right? Instead of moving like the 5 over here and the 2 in here, what we could do is move the times 2 to the other side of the parentheses. So we could do 2 times 3 plus 5. Okay, and that would still work. You could also do, you could change the order of what's inside the parentheses, because it keeps what's in the parentheses, what is grouped the same. You're just changing the order of that. So instead of 3 plus 5, you could do 5 plus 3 times 2. Or you can combine both of those and do 5 plus 3, and instead of times 2 at the end, you could do times 2 at the beginning. Okay, those will all work. But again, you have to have those groupings the same. Everything else you could change the order of. So you can change the order of whatever's inside parentheses, or you could change the order of what's outside. So put whatever's being multiplied after before. But you have to have those groupings the same. And you have to have those parentheses. Otherwise, you get stuff that's not actually equivalent. Okay, so couple of exceptions to the rule of same operations there. If you have parentheses and you don't change what's being grouped, then commutative property will still hold. Okay, so again, the big thing with commutative property is reordering, not regrouping. Okay. Associative property is the opposite. So with associative property, we're actually regrouping, but we have the same order of the numbers. Okay, and this also has the same rule of only regrouping the same operations. Okay, but let me kind of back up a little and talk about maybe first a way to remember that it's regrouping, not reordering, and then talk about what regrouping means. So with associative property and how to remember that it's regrouping that we're talking about, not reordering, think about the word associate. Okay, like I associate with my friends, right? I communicate with my friends and, talk with them, I'm with them, I associate with them. Okay, but you could also associate with a different group of people, like your family. Okay, so you can associate with different groups, but still have the same overall, like, giant group of people that you associate with. Okay, so that's how I remember that association is regrouping. Obviously, if you think of your own way, that's better. Fantastic. Okay, let's talk about what regrouping actually means. Well, there are different grouping symbols in math. Okay, the ones that you'll see the most are parentheses or maybe brackets. Later on, you'll see curly brackets quite often, but really parentheses are the ones that we'll see the most. Okay, so grouping symbols is good to know because you can't really regroup things if you don't know what's being grouped. Okay, let's talk about some examples now. If I were to have, let's say, let's do 2 plus 4 plus 6. And I'm going to put parentheses over the 2 and the 4. Now, order of operations, PEMDAS, we would always do what's inside the parentheses first. Okay, so if we were asked to solve this expression, 2 plus 4 grouped and then plus 6, we would do 2 plus 4 first, which is 6. And then we add 6, and it would be a total of 12. Okay, now associative property says that we can regroup, so change what's inside the parentheses without changing the answer. And the key thing is you do need to keep the same order. So it's still going to be 2, 4, and then 6. 2, 4, and then 6. But instead of having the parentheses, I'm going to use a different color here. Instead of using the parentheses over 2 and 4, you're going to move them to 4 and 6. So again, the order is still the same, still 2, 4, 6, 2, 4, 6. But instead of 2 and 4 being grouped, it's going to be 4 and 6 being grouped. Now let's prove that these would be the same solution. Again, we would do parentheses first, so 4 plus 6 is 10. And then we add 2, and we get a total of 12. So that does work. Okay, so that's what it means by regrouping. Again, the order of the numbers is still the same, but you're just picking up those parentheses and moving them to a different set of numbers. Now, this will also work with multiplication. So let's do maybe 3 times 5 times 7, okay? Again, order of operations, if we were asked to solve this, we would do what's inside the parentheses first. So we have 3 times 5, which is 15. And then times 7 would give us a grand total of 105. Okay. Associative property says that we can regroup this expression without changing the answer. So again, the order of the numbers will still be the same, 3 times 5 times 7. But instead of having the parentheses over the 3 and the 5, we're just going to shift it to the 5 and the 7. So let's see if that changed our answer. Again, order of operations, we would do parentheses first. So 5 times 7 would give us 35. And then we have the times 3 left. So 35 times 3 would give us a grand total of 105. Okay, so that does work. Now, again, I want to emphasize that you can only regroup the same operations for this to work. Okay, what I mean by that is if we had something like 2 plus 5 times 6, and the 2 and the 5 are grouped. Let's first find the answer to this, and then see if we can regroup and still get the same answer. So again, order of operations would be parentheses first, so 2 plus 5 would be 7. 7 times 6 would give us a total of 42. Now, if I were to regroup this but not change the order, so I'm just doing associative property, okay, order is the same. I still have 2 plus 5 times 6, but instead of having the 2 and the 5 grouped, we're going to group the 5 and the 6. Let's see what happens to our solution here. Again, parentheses first, so we would do 5 times 6, which is 30. And then add 2, and we get 32. So these answers are not the same, okay? That's what I mean by we can only regroup same operations, okay? If we regroup when something's being added and then multiplied, added then multiplied, we will not get equivalent expressions, okay? So that's what it means by we need to keep the same order, but we can regroup, but it will only work if we have the same operations grouped. Okay. Okay. Let's go to the next one. No, not that one, this one. Distributed property. Okay, this one is definitely the one you will be using the most. Again, we're just going over a really basic overview of what these properties are, just so you can recognize it. And then when we get back from break, we're going to go over these in a lot more detail with solving equations. So keep that in mind while I'm explaining this. Okay, distributive property. The big thing to take away with distributive property is that you're going to multiply whatever's outside the parentheses to everything that's inside the parentheses. Okay. Now, let's back up for a second, and I'm going to talk about parentheses for a second. If you ever see a number outside of parentheses without any operation between the number and the parentheses, so instead of saying like 2 plus this or minus or divided by or times, you just have 2 outside of the parentheses like that, it means to multiply. Okay, so having the 2 outside this parentheses here means 2 times 10. Or having the 3 outside the parentheses here means 3 times this grouped amount. Okay, so that's a good place to start with distributive property, is recognize that you're trying to multiply this 2 by whatever is grouped, or multiply this 3 by whatever is grouped. Okay, so with distributive property, I'm going to scoot this direction for a moment. With distributive property, let's say that we have, something like this. 2 times, remember that no operation there means multiply. So 2 times 3 plus 4, and the 3 plus 4 is grouped. Let's first just solve this and see what we get, and then we'll worry about this distributing. So again, to solve this, we would do order of operations, so parentheses first. So 3 plus 4 would give us 7. If we multiply that, well, that's supposed to be a 2, we would get 14. Okay. What distributive property says is that we can multiply whatever is outside the parentheses by everything inside the parentheses, and then find the sum, and it will give us the same answer. Okay, it's kind of a long sentence, so let's do this together. Again, we can multiply anything that's outside the parentheses, so 2, by anything that's inside the parentheses, so we're going to do 2 times 3, and then we're going to add, because this is being added here, we're going to add 2 times 4, because again, we're multiplying whatever is outside by everything that's inside, so 2 times 3, 2 times 3, and 2 times 4. And then let's find the answer. So these orange. 2 times 3 would be 6, and then 2 times 4 is 8. If we add those together, we get 14. So that matches. Okay. Now, some of you may be thinking, why would we want to, do this extra step of multiplying separate first and then adding versus adding then multiplying one number, right? And the answer is, well, it doesn't actually make a difference for this particular situation if you have all numbers. Okay, if you're dealing with all numbers, then it is usually faster to do this way. Okay, sometimes it can make it look a little less complicated doing distributive property, especially if you have like fractions involved. But the main reason we teach you distributive property is because starting next module, you are going to have things called variables in your expressions. Right? Variables are basically letters that represent numbers. Okay, so we would have something like 2 times, and instead of maybe 3 plus 4, we have y plus 4. Okay, and I'm not going to go into this discussion right now, but just trust me on this. We cannot actually add y and 4. It would just be y plus 4. Whereas up here, we could add 3 plus 4, and that makes things a lot easier, and then we just multiply by 2. But with variables involved, you cannot combine those. So to simplify this expression, you would have to distribute what's outside to what's inside to actually get the simplified version of this expression. Okay. And again, this will start making a lot more sense once we really start using these properties and solving equations. But for now, I just want you to be able to recognize when distributive property is happening. Okay. So in this particular example, we would again take whatever is outside the parentheses and multiply it by what's inside. Okay. So we would have 2 times y, right? 2 times y, and then 2 times 4, and we add between because we have the addition sign here, okay? And then we would simplify what we can. Now, 2 times y, again, I'm not going into details on why this is the case right now, so you'll have to just trust me for a couple days on this, and then when we get back from break, I'll explain all of this. But 2 times y would simply be 2y. And then 2 times 4, we would get 8. So this right here is the answer to and the simplified version of this. Okay. So again, that's why we teach you distributive property, among other things, is because sometimes we won't just have numbers, right? Sometimes it won't be as easy as that, and you can't just add and then multiply. You have to distribute in order to get the answer. Okay. And again, the gist of this, and I'm trying to emphasize this as much as possible, is not to necessarily be able to distribute right now, but I want you to be able to recognize when distributive property is happening. Okay. And again, that would be whenever there is something outside of parentheses that you are multiplying to everything inside the parentheses. Okay. So if we had like A, B, C, right? The distributive version of that would be A times B, and then A times C. Okay, so that's kind of the generic version. Okay. Let's talk about multiplicative inverse. And you have seen this before, actually, when dividing fractions. So think back to like keep, change, flip. I don't actually like that saying. I usually use multiply by the inverse, which is where this will make more sense. So multiplicative inverse states that any number multiplied by its inverse will always equal 1. So literally any number you could think of, if you multiply it by its inverse, it will always equal 1. The exception to that is if that number is 0, and you multiply it by its inverse, which would be 0, you will get 0. That's the only exception. Now, before we get into an example, I wanted to point this out. Inverse means you basically are swapping the numerator and denominator. So if we have a numerator and denominator, the inverse of it would be the denominator over the numerator. Okay, let's go over some examples here. Let's say we have, oh, sorry, my bad. Let's say we have the fraction 5/2. Okay, the inverse of that would be 2/5. Remember, we're just swapping the numerator and denominator. Okay. If we were to multiply 5/2 with its inverse, which is this, we should get 1. So let's check that out. To multiply fractions, think back to the beginning of the year, we would multiply going across, so 5 times 2, and then 2 times 5. So 5 times 2, we get 10. 2 times 5, we get 10. To simplify that fraction, 10 divided by 10, we would get 1. And if you don't believe me yet, let's try another one. Let's say we have the number 17. Now, this one's slightly different in that we have a whole number 17. So think back to the invisible math, right? If you ever have a whole number, it's the same thing as saying that whole number over 1, okay? So the inverse of that then would be 1 over 17. So if we multiplied 17 by its inverse, 1 over 17, we would get 17 times 1 is 17. 1 times 17 is 17. We would get 1, okay? This would also work for negatives, okay? If we had, let's say, 1/3, negative 1/3, and we multiply by its inverse, which would be still negative, because we're not talking about opposite, we're just talking about inverse, 3 over 1. Well, we have 1 times 3, which is 3, and 3 times 3, which is 3, and we have a negative times a negative, which would give us a positive. So 3 divided by 3 would give us a positive 1. Okay, so it works with negatives, it works with fractions, whole numbers. You could even do this with pi, the infamous number pi. The inverse of pi would just be 1 over pi, right? Same thing like the whole number, okay? And you would get pi divided by pi, and anything divided by itself is just 1, okay? So this literally works with every number except 0. So again, multiplicative inverse property states that any number multiplied by its inverse will be equal to 1. Okay. Additive inverse. We're getting close, guys. Additive inverse. This one we've been talking about for a few weeks, so I'll kind of just breeze through this one. Additive inverse property states that any number plus its opposite will be 0. And what we mean by opposite here is negative versus positive. Okay, so any number. So let's say we have 1/2. Its opposite would be negative 1/2. So if we add its opposite, it would be 0, right? 1/2 minus 1/2 would be 0. Or you could do 1,311. The opposite of that would be negative 1,311. If we added those together, we would get 0. You could do this with pi. If we have negative pi and we add its opposite, which would be positive pi, we get 0. Okay, so there's additive inverse. And again, I kind of breezed through that one because we've been talking about it for a couple weeks now. Now I'm going to go over 3 more properties that are not listed on the front page of that packet, but I would write them down because they are still very important. The first one is identity property of addition. So keywords there, identity. So think about the word identity. Identity, I mean, really identity means, right, it's itself, or the self, or sense of self, or you, like what you're about, right? So to kind of remember what identity means is essentially we're taking any number and either adding something or multiplying something to make it equal itself, okay? What I mean by that is we could take any number, so let's say 13. Any number plus 0, so 13 plus 0, is going to equal itself, where we started, its identity, okay? You could also do this with multiplication, but instead of multiplying by 0, we would multiply by 1, because any number multiplied by 1 will be itself, okay? So identity property is pretty basic there. Any number plus 0 will be itself. Any number times 1 will be itself. The last one is even more simple, the 0 property. Anything multiplied by 0 is 0. Okay, literally any number. Any number you could think of times 0 will always be 0. Okay, again, works for literally any number. One thing I wanted to point out, because a couple of my students asked about this in every class, What about dividing by 0? Would that work? The answer is no. No, it would not work. Because, and I'm not going to go into detail on this, but any number divided by 0 is actually undefined. Okay, if you were to try that in your calculator, just any number, so 11 divided by 0 or 1/2 divided by 0, it will give you an error message. Okay. And the best way to think about it is maybe like, let's say we have a plate of cookies, of 5 cookies, and we divide it between 0 people, right? How many cookies would each person get? Well, there's no people to divide the cookies into, so it would be undefined. It's an error. It's not possible. Okay. So keep that in mind. 0 property, anything multiplied by 0 would be 0. Okay, we're going to go over the next page together real quick, and then I'll let you do some by yourself. So flip the page. Here we go. Let's look at number 1. Which example shows the additive inverse property? Maybe pause the video and see if you can find it, and then come back and check. All right, so let's take a look at each of these choices, and then that'll help us find the answer. So let's look at A. We have A times, remember if there's no sign there, it means times, okay? So A times B plus C. And the difference between this part of the equation and this part of the equation, notice we have an A attached to both B and C, whereas here we just have it in front of parentheses. Here there are no parentheses, okay? So what this option is describing is the distributive property. Okay, we are distributing the A, we're multiplying it by both things inside. So A times B and then A times C. So that would not work. Option B, we have A plus B plus 9 equals A times 9 plus B. This is a little tricky. Most people would say associative, and you would be right if there was a plus sign between that A and the parentheses, because then we'd just be changing what's being grouped. However, it's actually changing the operations from adding to multiplying. So this actually isn't even a property because they are not equal expressions. Okay, they're not equal. So that doesn't even work. Let's look at C. C, we have A plus A plus A equals 3A, which is true, right? 3 of something would be like multiplying it by 3, but it's not actually a property. It's just basic addition and multiplication, which leaves us D. So we do know the answer D, but let's talk about why. So we have negative A, and then here we have subtracted by a negative, or subtract negative B, and here we have plus B, plus a positive B. So this is true because additive inverse, remember, is the opposite. So instead of subtracting a negative, we're going to add a positive. So that shows us additive inverse property. All right, let's look at number 2. And again, I would suggest pausing the video, trying to find the answer, and then coming back. Which example does not show the commutative property of addition? So let's look through all these real quick. Option A, we have 4 plus x equals x plus 4. Okay, so we're adding the same things, x and x, 4 and 4, but they're in a different order. And we are adding. So this does work. Remember, we want to find what's not showing it. Option B, we have A times B and B times A. So we are switching the order. Right? But here we're looking at multiplication. not addition. So B does not work. Let's look at C. C, we have A plus B equals B plus A. So we are adding on both of them, and we are just swapping the order, right? Swapping the order, so that works. Let's look at D. D, we have 3x plus 4y and 4y plus 3x. So again, we are just switching the order of these terms, which means that does show commutative property of addition, okay? And we wouldn't say commutative property of multiplication, even though there is multiplication happening here, 3 times x and 4 times y, because we didn't switch what was being multiplied. If our answer had been from 3x plus 4y to x times 3 plus y times 4, then we would say commutative property of multiplication. But since we swapped what's being added, the order of the addition, we would say that that definitely works. So the answer then would be B. Okay, on this one, here we go. Those were answers. Okay, this is number 3. Basically, you're given an expression, you're given a property, and basically told to write an equivalent expression using that property. Okay, so for example, let's look at the first one, distributive property. Remember, distributive property means multiply whatever's outside to what's inside. So if we wanted to rewrite that without finding the answer, just rewriting it, we would say 4 times 5 plus 4 times 7. So multiplying what's outside to everything inside. So I'm going to let you do the rest of them. Commutative, associative of multiplication versus addition, multiplicative inverse, and additive inverse. These two, just find the answer. You don't need to rewrite it in an equivalent expression. Okay, so maybe pause the video, do that, and come back. Okay, hopefully you did those. Let's talk about it. Commutative property, again, we're reordering. So essentially, you can switch any of these. This one, you could have multiple answers. So you could switch the 6 and the 4. You could switch the 4 and the 7. You could switch the 6 and the 7. Or any combination of all of those. Okay, so multiple answers there. The next one, associative property of addition. So we're changing what is being grouped. So the order will still be the same, 9 plus 5 plus 3. But instead of 5 and 3 being grouped, we're going to have 9 and 5 being grouped. So we're just basically picking up these parentheses and moving them over. Associative property of multiplication is next. So again, associative property will still have the order the same. So 11 times 8 times 3. But instead of 11 and 8 being grouped, you're going to pick those parentheses up and shift them over. Multiplicative inverse. This means, again, that any number multiplied by its inverse, so 1/4 times 4, will be equal to 1. And you can test it out. 1 times 4 is 4. 4 times 1 is 4. 4 divided by 4 is 1. All right, last one, additive inverse. Additive inverse means that any number plus its opposite, so the positive plus the negative, equals 0. 9 plus negative 9 is 0. Hopefully this is making sense. 2 more that we're going to go through together, and then you've got some to work on your own. Number 4. How do we know that this expression is equivalent to this expression? Well, let's see what's happening. On this first one, let's actually first look at the order. 8, 9, 3. This one is also 8, 9, 3. So we know it's not commutative property because that'd be reordering. Let's see what's grouped. Here we have 8 and 9 grouped. Here we have 9 and 3 grouped. So what property goes with regrouping? Well, you should say associative property. Okay. So that's just basically being able to identify what property is being used. Same with number 5. How do we know that 2 times 1/2 is equivalent to 1? What property would describe that? Well, it would be the multiplicative property. Okay, which again states that any number times its inverse will be equal to 1. All right. You're up, buttercups. Here we go. The second page of the packet, so the second full page, okay, the one that says working with properties of mathematics at the top. That whole page, front and back, I'll say that again, front and back has 17 problems. You do not need to do all of them. You need to do 9 of them. Okay, you can choose any 9 you want. I would suggest if you get stuck on one to choose a different one. Okay, so do 9 problems. It's due tomorrow. Okay, if you're an online absent quarantine student, you can take a picture of your answers and submit it through Google Classroom, or turn it in with the drop off. Okay, so you're on your own on that one. I'm not gonna give you the answers at all. So do those, complete 9 problems out of the 17, and then turn it in. Okay. And if you have any questions about the properties of operations and being able to recognize what's happening with them, please just email me. All right, good luck.